The push press is one of the most athletic, explosive movements performed by weightlifters. It is a variation of the Olympic jerk, engaging the entire body to drive a heavily loaded barbell from the front rack to the overhead position, with knees, hips, shoulders, and elbows fully extended. The series of involved movements is designed to generate momentum to accelerate the bar overhead quickly and forcefully, developing power and speed and improving whole body coordination. The 5 phases of the push press are, from left to right, the start position or setup, the dip, the drive into the overhead position, the lockout, and the return. The barbell and the body must move in a vertical, straight line when viewed from the side in order to maintain optimal bar path. The push press is a triplanar movement. The necessary joint actions occur across the sagittal, frontal, and transverse planes. The primary joint actions during the dynamic portion of the movement are flexion and extension. However, degrees of external humeral rotation and adduction, scapular retraction and protraction, and external femoral rotation are seen throughout the entire movement. External rotation of the femoral and humeral heads within their respective sockets is crucial for maintaining joint stability. The primary movers or agonists involved in the push press are, in order of activation, the quadriceps femoris, gluteal muscles, anterior deltoids, and triceps brachii. From the front rack position in the setup, the quadriceps and gluteal muscles lengthen, allowing hip and knee flexion. Abrupt and simultaneous contraction of these muscles over a short contractile length begin the overhead acceleration of the barbell. As the barbell leaves the shoulders, the anterior deltoids and triceps engage to slow the bar's deceleration. As the bar's acceleration slows, the gravitational forces become stronger relative to the barbell's velocity. The deltoids, triceps, and spinal erectors assume the load and stabilize it overhead. Sequentially, the antagonists are the biceps femoris, the rectus abdominis, the latissimus dorsi, and the biceps. On initiation of the dip, the biceps femoris contract, inducing knee flexion, and decelerate the forceful contraction of the quadriceps femoris, inhibiting hyperextension of the knee joint. The iliopsoas and TFL decelerate the extension of the hip joint to avoid hyperextension, and the rectus abdominis counteracts the spinal erectors to stabilize the trunk and prevent pelvic tilt. The latissimus dorsi lengthen completely at full contraction of the anterior deltoid, and in concert with the muscles and tendons of the rotator cuff and the labrum, prevent the humeral head from dislocating from the glenoid fossa. Finally, the biceps decelerate contraction of the triceps brachii, preventing hyperextension of the elbow. When considering the body in toto and the push press as a total body movement, it becomes readily apparent that the agonists are not the only muscles responsible for generating and supporting this series of movements. Each primary driver has a system of synergists comprised of neutralizers, stabilizers, and fixators that work to control, cancel, or otherwise delimit muscular movement to successfully and safely complete the movement. Synergist systems involved in the push press are the quadriceps femoris group, the iliopsoas group, the rotator cuff, and the muscles of the upper back. The most effective technique to achieve overhead lockout is to maintain a vertical bar path from the front rack position to the overhead position. Deviation from this bar path reduces economy and can lead to injury. Common errors include, throughout the setup, humeral abduction and failure to externally rotate the femur to generate torque through the hip joint. During the dip, failure to maintain external femoral rotation, valgus fault, and lumbar flexion. Throughout the drive into the overhead position, internal humeral rotation, and hyperextension of the lumbar spine. Given the total body nature of the push press, the activation of the powerful hip flexors, and the potential for acceleration, the push press enables an athlete to lift more weight overhead than they would be able to press strictly. The dynamic nature of the lift and the explosive nature of the knee flexion over a short contractile length preceded immediately by the eccentric lengthening of the quadriceps increases the possibility of injury, but through proper coaching, biomechanical analysis, and appropriate loading, the push press is safe and favorable for athletes.